Good afternoon. I just want to tell you a story of ISRO that started in a very humble way from a fishing hamlet in the southern tip of India, and in the year 1963, a French rocket took off from there. What was unique about the Indian space program is the indomitable vision of the founder. And over the years, we have made a foray into this wonderful world of space, technology, applications, and space exploration. ISRO is the nerve center, executive wing of the Indian space program. In 1972, the Space Commission was formed, the policy-making body, and the Department of Space. Structurally, all these three are headed by a scientist and under the direct charge of the Prime Minister. Just now, our Prime Minister told in a nutshell what we have been doing in space and with space. Let me just elaborate a few of those points. We have been extending the limits and exploring possibilities. Anyone in space knows that we are dealing with a complex technology. And these systems are quite large. They have to operate in environments which are generally not fully charted. The impact on the stakeholders at all levels is very high. And it is risky, prone to failures. Of course, we learn from the failures. And if you look at India, space applications, usefulness of space for the humankind, that has been the hallmark. That means we build systems which are required for improving the communication infrastructure in the country, for looking at Earth as a total system, for understanding our position, that is navigation. And this requires satellites, that requires self-reliance in rocket technology. And rocket science stands for something that is difficult to comprehend. And we have made a foray into it. In 1967, India's first rocket from that fishing hamlet weighed 32 kilograms. 50 years since then, in 2017, our GSLV Mark III had a mass of 630 tons. It put a spacecraft of 3,200 kilograms into geostationary transfer orbit. That's the way we grew. We have a PSLV, which is globally acclaimed, that has launched not only the Indian satellites, but 238 satellites of 28 countries so far, including one of UAE. We have a GSLV, much more powerful. It's also a reliable rocket. That's on one side. Recently, India's 100th satellite was put into orbit. And the satellites that we have made so far on communications, that has revolutionized the infrastructure available in the country, in the broadcasting area, emergency communication, data connectivity, these are all now made possible because of this revolution. If you look at the Earth observation satellites, India has one of the best constellation of satellites. They look at atmosphere, meteorology, they look at oceans, they look at the land, water resources, the forestry, agriculture, and so on. And these two put together, they do a great job whenever any disaster occurs in the country, be it cyclone, be it flood, or any other type of natural disaster. And if you look at navigation, we have several global systems, and India has today an addition that is a regional navigation satellite system. So this is a constellation, and today we have close to 40 satellites in the orbit to provide these services. And if you look at how do we realize that in the country, and how do I use this word self-reliance, which is an obsession of the Indian space program, not simply an objective. And that is possible with national synergy, ISRO on one side, and a vibrant space industry that has been created systematically from the 70s. And when we had the launch of the Mars orbiter, we had 125 firms from India, large, medium, small, micro, from the private sector and public sector participating in that program. And of course, we look forward to what we can do in the future. One turning point was in 2000, and that turning point was our mission to moon. We had always this vision of using space for the humanity. But we did not stay still. As our capability went up, as the national aspirations went up, as the globe also transformed, we looked at what more we could do. In the year 2000, we started. In the year 2008, we had the Chandrayaan mission. What did it signify in terms of technology? Till then, we were putting satellites around Earth, up to 36,000 kilometers. And when we had this Chandrayaan mission, we went up to 400,000 kilometers, first time beyond the Earth. And we had a deep space station to navigate this Chandrayaan precisely to an orbit around Moon that was 100 kilometers around Moon. More than the Indian participants, that was a forum for international cooperation. We had instruments from US, UK, Europe, all coming together in this platform. And that platform provided or facilitated discovery of water using the NASA instruments. So that was an essay in international cooperation in space. And that emboldened us to take up this task of Mars orbiter mission. When you talk about the nearest neighbor, Mars, it's quite a risky job. And if you look at the history of Soviets, Russia, US, Europe, they all did that, and 60% failed. But in space, a failure leads to learning, and we advance. So we had the benefit from the learning of our forerunners on where we can go wrong. That was the first part of it. When we talk about this planet, it is 55 million kilometers when it is close to Earth. It is 400 million kilometers when it is far away. Communication engineers will tell us that it requires 20 minutes of time for a signal to reach that spacecraft. If it is not healthy, we will know after 20 minutes. And when we send a corrective signal, it will take another 20 minutes. And we also require sometimes time to think and decide what to do. In this time frame, it would have worsened. What we needed to provide there was to empower the satellite to look at its health and take decisions, autonomy. And that autonomy was provided to this Mars orbiter spacecraft. What the ground controllers normally do were all translated into algorithms, decision rules, put in the computer, did thousands of simulations to ensure that spacecraft doesn't take a wrong decision. That is one part of it. The second part, sheer distance requires high power in communication. A deep space ground station that we had for Chandrayaan, 400,000 kilometers, here it has to go up to 400 million kilometers. So we had to enhance. Not only that, we needed global network, and we got that support from NASA with their 3 ground stations. This was another aspect of it. More importantly, going back to the decision, we took that decision in August 2012. The government of India decided India is going to get into Mars orbiter mission. And we said we will avail the earliest opportunity. When I say opportunity, once in 26 months only we can have a mission to Mars. The immediate one was 2013. And if we miss that, the next one is slightly more difficult one, we would have missed another 5 years. So it is a grit and the determination of the space community and the government that India is going to get into Mars orbiter mission. And that was announced by the Prime Minister on the Independence Day. What was the condition of the world? Curiosity had landed on Mars in August first week. And for the MAVEN mission of NASA, they had done several years of work. And after all the review, they authorized that spacecraft could be integrated now for the launch. And here, we were just starting saying that we will do the Mars orbiter mission. So it was considered unbelievable, a daunting task, an unbelievable schedule. But we did it. And going to Mars, we could not compromise on any tests, any performance, quality requirements. All we had to go through because one is going through very difficult environment. Here was the test of our ability to do systems engineering and project management. Normally, a spacecraft will take about 1 year for integration and everything has to proceed. But here we had only 1 year time. By August, September 2013, we had to have the spacecraft ready at the spaceport. So what we did is the following. We did judicious parallelization of all activities. If you talk about any spacecraft, there are some standard items which are there. There are some totally new developments to do. And there are certain systems which have been adapted. We started them parallelly. We started the integration with whatever was available. And by about June, July 2013, all the adaptations got integrated into the spacecraft. It is a very critical schedule. And there were new systems. So we did testing with what was existing, especially in terms of communication system. There are specific frequencies which are allotted for the deep space mission. And we have to get those things retrofit and do the testing. And finally, in August end, we were ready with the spacecraft. There were people who told India is going with an insane schedule. And that point of time, they said, India is serious. The question is, how do we launch this? We had a limitation. We had only a PSLV, a small vehicle, which is almost 1/10 of the power that the American satellite launch vehicle had, the Saturn. But what we did was the following. The physicist will tell us, if you want to go to Mars, you need to kick the satellite from the Earth at a velocity which is called the escape velocity plus an excess over it. We couldn't give it in one go. So our PSLV did that 9.8 kilometer per second. 1.5 was added by the satellite itself with the fuel that it had, but it was done in steps. It took about 3 weeks for us to reach that place. There was difficult environment which it had to go through, but the beauty was during these 3 weeks, when it was going around Earth in various orbits, we checked out all the systems, and we also unearthed there was still one bug. So that was a boon. But on December 1st, we directed precisely that spacecraft towards Mars. Then people said India is into the business. And what was the challenge on the December 1st? This spacecraft has to travel a long distance around Sun and then finally get into Mars vicinity. Then we have to capture it. This travel is almost 660 million kilometers. And while traveling, it goes through the forces from various celestial bodies, predominantly Sun. So before 300 days, we needed to estimate what is going to be the perturbations on this spacecraft for the next 300 days and move it into that right arc. And we did that. We kept also some fuel for corrections if necessary, but we didn't have to use much of it. And what was the precision required on arrival at Mars? 500 kilometers plus minus 50 after travel of 660 million kilometers. That was the time the mathematicians and the physicists led the mission, and they were able to compute correctly. And doing that plus the calibration of that using the deep space ground stations, everything worked finally. This was the launch, and this is how we reached there. September 2014, we had that great moment when a spacecraft which was going at very high velocity had to be applied with a brake. And that brake had to be applied using a propulsion system or a small rocket in the spacecraft, which was sleeping for the last 300 days. Restarting that itself was a big task, and is one area where we could have failed, but we did all the tests over the previous 1 year to ensure that it will work. And finally, it reached the orbit. And the beauty of it was happening there. But we were knowing that only after about half an hour. One is the time required for the signal to come. Second one, it goes behind the Sun and the Mars, and visibility is not there. So we waited. Our Honorable Prime Minister was there on that day with us, and we shared that tension and that ecstasy which came out of it. Now we reached there. The question is, how do we manage? Autonomy was to be tested, and there were occasions, at least a couple of weeks, when the spacecraft did not have any contact with the ground, but it worked. It is still there. It has done good science. And when we started the mission, we set our primary objective is that a spacecraft should be able to be orbited, that we achieved 100% mark. There were 5 instruments. We said if there is a good life, we can do experiments. Good life has come. Because of the precision in our navigation, we saved the fuel, and still we have fuel for a few more years. So 3.5 years plus has been the life of this spacecraft. Good scientific results have also come out of this mission. So this is something that happened, and this is one section of the Mission Control Center that you see. And I want the youngsters to see, the young boys and girls who were there with us, to manage this mission, and we were learning en route. On one side, space is for the humanity. On the other side, space is to understand about humanity, and that's what we have been doing it at very low price.